And this is Mission Control Houston, welcoming to our program today Julie Robinson, the International Space Station Program Scientist for NASA. Julie, hi, how are things in Denver?
Oh, it's great here. There's high energy. This is the first time we've ever had a conference that had all the disciplines from International Space Station research and technology development all in one place. And so the breadth of topics has been just amazing.
And you have three basic themes for International Space Station research that you're working on. Can you tell us a little bit about those?
Well, in the sessions that were held yesterday, the introductory sessions for the meeting, it really emerged from the comments from our Associate Administrator, Bill Gerstenmaier, all the way through the scientists that we are seeing results coming from that early utilization of the space station that we did during assembly, and that we're starting to see the rate of those results going up rapidly now that we've shifted to full research. And from those results, we see basic discoveries, new knowledge that we never had before. We see new Earth benefits coming from that, where that knowledge turns into things on Earth that save lives and improve our economy. And then we see the benefits for future spaceflight as we prove technologies and add knowledge that will help us go beyond Earth orbit in the future.
Well, that's really interesting, Julie. And so you've been on a couple of different panels there.
Yesterday we had our first plenary panel that covered a sampling of the top science and technology results over the last few years. And it was great because we had scientists in the life sciences talking about a possible new cure for Duchenne's muscular dystrophy and development of vaccines for salmonella food poisoning. We had discussions of new physical science results that led to better ways to develop fuel tanks and a number of different patents for products back here on Earth. The Naval Research Laboratory talked about their advances in using hyperspectral remote sensing from Earth to map the coastal oceans. And then there was even a discussion of new discoveries in astronaut health in terms of their vision loss due to a previously undiscovered effect of being in space on the central nervous system and on the venous pressure.
There was another panel today that you're participating in as well?
That's right. Right now, I just stepped out of a panel that was focused on exploration technologies being developed and tested on the International Space Station, and it kicked off with Jill McGuire from Goddard Space Flight Center talking about the robotic refueling mission, which is really pushing our ability to use robots to repair spacecraft in orbit, and especially those spacecraft that had not been designed for robotic repair. And that was just a really strong presentation. Also, scientists have been talking about laser communications and pushing that envelope using tests on the International Space Station. So what we're really seeing is advances in science happening and then advances in technology, all enabled by the platform that serves so many users in low Earth orbit.
And have you had anything that surprised you in the presentations thus far?
You know, it was funny at lunch. I was polling a number of different people yesterday and saying, what did you learn? What did you learn? And every single person had something different that they had learned about. A lot of people were surprised they did not know about the astronaut vision loss problem, so that was something new to them. Others were really surprised. They knew in our capillary flow investigations that was important for fuel tank design, but they didn't realize all the different Earth benefits that come from being able to use capillary flow as a tool instead of a pump to move fluids around in tubes. And so that was also surprising to a lot of people. The scientists from Alpha Magnetic Spectrometer at MIT also presented some preliminary data from their first 18 million observations of galactic cosmic rays. So just a real breadth and a lot of surprises here.
And Julie, I heard million, but I think it was billion, right?
You're right, it's a billion. Thank you.
Okay, I didn't want to undersell that.
That's right.
And so there are a lot of forest fires going on in Colorado. Are you experiencing any of the effects of those?
Well, it's definitely, a big story here. A fire close here in Colorado Springs is the top priority fire across the nation because of the number of homes that have been destroyed. uh, the astronaut crews on orbit. The timing that when they're going over these fires today is a little bit off, but they are taking a look for it, capturing images of the fires, and that's a valuable service through our Crew Earth Observations program. We have a new network in place as well to help distribute images of disasters throughout the world when they come in, and so we work with the U.S. Geological Survey on the International Disaster Charter so that ISS can help with that. As we add new instruments to the space station, and there was a great session yesterday about all the new Earth remote sensing instruments that are planned, each of those instruments will also be able to participate in that network.
Has there been a lot of discussion about opportunities for additional research at the conference?
There have been, and one of the great things about having all the different disciplines here is scientists are talking across disciplines and getting new ideas. The U.S. Department of Agriculture, for example, had representatives here, and they've been looking at all the different things that have been done to date and mapping those to USDA research objectives. The USDA has an agreement with NASA to use the space station as a laboratory, as does the National Institutes of Health. And so seeing those kind of uses developing. Then on Thursday, there's a special workshop all day, special free workshop for all potential new users of ISS to help them understand what you need to do to get on board, how to build the right partnerships so that you don't have to learn anything complicated about the way NASA works. You can just take an experiment you do in your lab and send it up into space.
And is there a specific place that people have ideas for research that may not relate directly to NASA's mission where they should go to try and get clued in on how to participate in the National Laboratory?
Oh, absolutely. A major sponsor of this conference is CASIS, the Center for Advancement of Science in Space, and they were selected in August as the manager of ISS as a national laboratory. And so that means that we now have really three kinds of users coming to the space station. There are our international partners who bring experiments to the space station. There are the NASA-funded users. And then there are now ISS National Laboratory users, and they are from other government agencies and the private sector. I saw some great new work under discussion for use of the ISS National Laboratory yesterday. Things like a new way of developing tumor models that you could use in space to test things that in terms of studying tumors that you can't do here on the ground, and even new ways of doing observations at a very fine resolution that are important for agriculture.
Well, Julie, that sounds like a really interesting conference, and it sounds like the start of something that can grow in the coming years as we have this conference each year. I want to thank you so much for joining us from Denver, taking time out from your panel. Any last thoughts before we sign off?
I think that the real thing that you see here is that ISS is in a new era, and that era of research and development. You can feel the energy here. You see all the new ideas. You see all the people who have gotten funding for bright ideas and those things getting ready for going into orbit or actually starting their operations on the space station. The other great thing that I see as a change here is the level of customer service that the ISS is able to offer to help new users, people who don't understand NASA or don't understand spaceflight, get their ideas to orbit. And so it's really a wonderful time in the history of the space station.
Well, and in the past when we had shuttle mission research, it was a kind of a different paradigm. It took a lot longer to get an experiment on orbit, and you only had a couple of weeks to do your experiment, and then it might be quite a while before you could refly it. That's changed now, hasn't it?
It really has, and that's probably the most important feature of the International Space Station is that 24/7, 365 research can go on there. And when somebody has an experiment and it doesn't work the first time, we just circle around, fix it, and try again. So having the crew member there, having continuous operations, and then really importantly is because it's always there, we can take new research, and get it up to orbit quickly. So, a piece of cell biology research, for example, that's using an incubator that's flown many times before could be implemented and put on the very next flight to ISS and operated within 6 months.